Hello, and welcome to another Farsoon Parameters Guide. My name is Ray Jones, and today we will be discussing thermal control, why it's important, what to look out for, and how to adjust the correct parameters to achieve balanced thermal control within a Farsoon plastics machine. Why is thermal control important in SLS? The SLS process depends on an even and consistent heat source to produce usable and mechanically viable parts. Using heaters above the part bed, SLS machines preheat material to just below its melting point. A laser then scans a cross-section of a 3D model, heating the material to its melting point and fusing the particles together to create a solid part. If the area being scanned is too hot or too cold, deformations in the part can occur, causing both aesthetic and mechanical issues. Thermal control also consists of part piston, part cylinder, and feed size heaters. So there's a couple of things that we can look out for either in process or when the build is sintering or after the build is complete to identify if we have poor thermal control. The first being curling at the surface of the part bed, usually seen as corners or sides of a sintered layer peeking through a freshly laid layer of material. This is due to insufficient energy at the part bed. If curling is seen throughout the part bed, raising the part heater temperature is advised. If curling is seen in specific areas, for example, the front right corner or back left corner, then raising the corresponding heater ratios is advised. Next, we have orange peel, sometimes known or referred to as OP. This is seen vertically in the z-axis on a part surface. This indicates that the part or parts were built in a cold spot or that the part build temperature itself was insufficient. If a certain area of the part build is identified, then raising the corresponding heater ratio is recommended. If all parts in the build have orange peel, raising the part bed temperature is advised. Next, we have over-sintering. This is sometimes referred to banding or layer lines. This is seen horizontally on a part surface, similar to orange peel, and is caused when radiant heat fuses unsintered material to the sintered part surface. This is often accompanied by a harder than normal build part cake. This also indicates an excessive amount of heat energy, either coming from the part heater or if the part or parts are located on the outside edges, the cylinder heaters. To resolve these types of issues, lowering the part bed or cylinder temperature heaters is recommended. Next, we have warping of a part underneath the part bed surface, usually seen during the post-processing stage known as part breakout, when a part is visibly warped once placed on a flat surface or visually inspected. This can be due to insufficient cooldown times, either in the machine after a build or out of the machine in ambient cooldown. A 1-to-1 build cooldown scale is recommended for ambient cooldown. Once the internal temperature of the build is at least 85 degrees Celsius, then it is safe to break out the parts. If the recommended cooldown procedures are followed and parts are still warped, then the part piston heater and/or cylinder heaters need to be increased. Certain geometries are not conducive to the SLS process but can still be printed with marginal success. Medium or large, thin, flat parts are best oriented in a 2 to 3 degree angle, and 5-sided boxes should be designed with breakaway supports at the parts opening to deter shrinkage. Mechanical properties can also be affected by poor thermal control. Parts that are scanned in a build environment that is too cold can result in poor mechanical properties, as each layer may not have fused together properly. This can lead to poor tensile and elongation properties. Parts that are scanned in a build environment that is too hot can result in processing issues such as melt pools, curling from thermal stress, and dimensional inaccuracies, but depending on material, marginally increase tensile and elongation properties. Farsoon offers an intuitive thermal field control system made up of an 8 to 12 zone quartz tube heater array. A part piston plate heater and part cylinder blanket heater offer secondary heating throughout the entire Z height of the part cylinder. Using an IR camera or glaze test method, operators of a Farsoon polymer SLS machine can change the energy output of each heater tube to achieve a balanced thermal field at the part bed. Hot or cold spots can easily be balanced by either lowering or raising the corresponding heater ratio value. The overall temperature of the part heater, as well as each individual heater's duty cycle or ratio, is customizable to achieve proper heat distribution throughout the part bed. Each heater is labeled by its location within the heater array above the part bed. As with the part heater temperature, each heater's ratio can be altered both pre-build and in process and across the warm-up, build, and cool-down phases. So here we have Farsoon's BuildStar build setup software. As you can see, I have a build. Usually when I'm setting up a build for the first time on a machine, I usually either like to run a heat fence or tensile bars like you see here. Anytime you see orange peel or curling, it usually happens on the outside edges of the build envelope. Usually you get pretty good heat temperatures in the middle of the build. So putting in tensile bars, you can also use those to pull tensile to see what your mechanical properties look like on the outer edges. But we're going to run this build here. During the build process, say you have, or you're seeing curling in the back right-hand corner where this tensile bar is. We can go into build parameters, and we can go to show all parameters. And here on this left-hand side, you can see where we have our part heater ratios listed. We have the front, back, left, right, and then we have all the corners. So we're going to go to our right back ratio. So if you see that you're only getting curling, say in this very, very corner of the build envelope, then you're going to want to change this right back ratio. If you see that there's curling more in this middle back area, then you would change the back ratio. Usually when I'm changing heater ratios, I'll do it 0.25% at a time. This is usually around 2 to 5% duty cycle. So as you can see in our build parameter editor, we have columns for warm up, build stage, and cool down stage. And we're actually able to change the percentage for each stage. So in the build stage, we would want to change this to 1.25. I usually like to let the build run a couple layers just to make sure that it's absorbing that change in temperature, either if you're raising or lowering the heater ratios. And if that fixes the area, then that's all you have to do. If maybe you overshoot, again, if you start to see a melt pool, usually where the geometry of the part melts before the sintering process begins, then you can go back and decrease that percentage. But usually you change it 0.25% at a time. It's a good value to see where you're at. Next, we have part temperature. This is used for primarily if you see curling or orange peel throughout the whole build. Usually the build temperature is too low. So we can go into build temperature and we can raise the part bed temperature as a whole. Or inversely, we can raise the duty cycle, which will increase the time it takes for all of the heaters to warm up to that set point. Sometimes if you're getting curling, especially early on, right after the sintering process, usually the heaters are taking too long to ramp up, so we can increase the duty cycle to make up for that lost time. If you see melt pool, as discussed in our energy density video, we can decrease the part temperature the same way. Or if we have hard part cake throughout the whole build, this usually means that we're putting too much heat energy into the part bed, so we can lower the part temperature as well to compensate for that. Next, we can go down to cylinder heaters. And these, if we see that there's layer lines or banding on parts that are on the outside edges, say if we look at the edges of these tensile bars, or if we had, say, these parts on the outside edges, and we saw layer lines on these surfaces, then we would go into our build parameters, and we would lower our cylinder top and mid temperatures. Usually 2 degrees to 3 degrees is usually fine. If the part cake is very hard to the point where you need more than just your hand to break apart the material, then I would suggest lowering it by 5 degrees to start out with. Also, concerning cylinder temperatures, if you are getting builds where the material is too soft on the outer edges and you have parts that have warped, you can go ahead and increase the cylinder top and mid temperatures, anywhere from 3 to 5 degrees, and that should solve the problem for that. Lastly, we have piston heater temperature. This is going to be the heat source at the bottom of the build. You want to retain and maintain the heat not only at the bottom but in the middle and at the top. That's why we have heaters on the sides, on the bottom, and then why we have the part temperature heater. So to change that, if you see that you have parts at the bottom of the build that have warped post-build, then usually your part piston temperature is too low. So to change that, it's the same way. Go into part parameter or build parameters, and you go into your build and change your temperature that way. Thank you for your time, and I hope to see you in the next Farsoon parameter guide video.